Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, so continuing on with stats, we left it off on the last video where we were looking at measures of center and measures of variability. Okay, and all of this branch of maths falls under an umbrella called descriptive stats. Okay, and if you think about that word descriptive stats, you're literally using statistics to describe a body of data. So for example, when you look for the mean, you're looking for the center or the average. When you're looking for the mode, you're looking for the value that occurs most often. When you plot the data, again, you're describing the data in picture format, and so on and so forth. Okay, so that's descriptive stats, where you just have a body of data and you are describing it using statistical terms, statistical measures, and statistical charts. And then the other part of your statistics course is what's called inferential statistics. And that's where you use a body of data to make inferences or make predictions about an entire population. So that's inferential stats, and things like hypothesis testing and so on and so forth, or falls under that. So this is more of descriptive stats. So the first one that's here is a histogram. You would have done these as part of junior cert. You have bins, they're often called, but they are intervals or classes. Intervals is probably the easiest word, and you count how many students in this case falls within that interval. And then you plot the data on a histogram. The y-axis, the traditional y-axis is the frequency or the number of occurrences. The bottom then is the bins, so 0 to 20, 20 to 40, 40 to 60. Make sure you label the x and y. And then you need some sort of a key or note to say if your intervals overlap, like they do in this one, 0 to 20, 20 to 40, you have to say which one does 20 fall into, because it can't really fall into both. It needs to fall into just one. So that's why you typically see this note, 0 to 20 means 0 is included, but 20 is not. So 20 is here. So this is really 20 to 39. This is 40 to 59. Okay. The numbers here in this case go up in 20s. They don't have to go up in the same amount, because when you're doing a histogram, the frequency is really given by the area. Okay. It's the width by the frequency. So just in case you ever see a histogram that has different widths, that's okay. So in other words, if this was 40 to 50, it'd probably go up twice as high because it was half the width. Okay, so it'd be twice as high. So the area of the class has to stay the same, rather than you have to have the same intervals all the way across. Okay, so let me move on to your histograms. This is all about working with histograms and being able to, I suppose, plot them, read them, understand them. But I want to get on to this one where we can superimpose a curve over the interval, and I'm here in the example on the right of this book. So you can see there that there's a red curve superimposed on top of that histogram. And that's where our distributions or our curves or our frequency curves comes out of. And you'll have heard of the normal distribution curve or the bell-shaped curve. So that's literally sitting under that is a histogram. Okay, so they are related. So you can see it here in the top one on the left, the normal distribution, a very, very important curve. And it's very important because it is believed that if you take enough data about a lot of things in the world, they will fall under a normal distribution curve. But you have to take you have to have a large amount of samples. Okay, and you'll often hear Leaving Cert grades fit a bell curve. This is the bell curve, the normal distribution curve. And they do, I don't think they're forced into a bell curve. I think that's the natural order. So naturally, most people in the country will get, I don't know, grades in the middle. So there's your H4s, your H3s, H5s, something like that will be the majority of people. And then right at the top are your H6s, your H1s, I should say, I'm going the opposite way, and the bottom, your H6s and your H7s. So that is the natural order. They do fall under a bell curve. Okay, so that's the top one. It's fully symmetrical. The mean lies in the very center. Do you see that dotted C line? It's the mean, it's the value in the middle. It'll also be the median. The median will also be at C when it's fully symmetrical, and also the mode. The mode is the value that occurs most often, and you can see, especially from the histogram to the left of it, you can see that's what's happening there. Okay, you then need to consider skew. So data isn't always symmetrical. So if you look at the second one that says positive skew, okay, when you're talking about skew and you read much about it, you'll often see the description to follow the tail. Okay, so what does that mean? You see the way this data tails off to the right. So that red line is pulled to the right. Okay, that's positive skew. So in other words, you have the bulk of your data with low values, but then you have this tail of high values. And if you look at the placement, this is what's important. Where is the mean and the median and the mode in skewed data? So you'll see from the exam questions that we're going to do on this, you get asked to label this or roughly state which one is which. So the mode is the value that occurs most often. So it's got to be the peak of that curve. Okay, that is the value that occurs most often. So that's an easy enough one to label. Okay, the median and the mean then are relative to each other. So the median is the value that lies in the middle. So you have to eyeball it and somehow see, well, where roughly is the middle data point? And because there's so many data points to the left, that median will be more to the left. Okay, now you see the mean is higher than the median, and it always is in positive skew. And the reason for that is the big numbers to the right are making your average bigger. They're pulling up your average, they're pulling up your mean. Okay, so that is positive skew. Okay, and you'll often see it described as skewed to the right. Okay, and then the opposite, negative skew, so it's the bottom of the left page. This has a tail to the left. Okay, but again, the mode is easy enough to spot, but in this case, the mean is lower than the median. And again, it's because those low values are pulling down that median or that average. Okay, so really important that you know where the mean and the median are versus positive and negative skew, and that you're able to recognize a histogram that has skew in it. So to give an examples of skew then, wages in a company is a good one for positive skew. So think about any job that either you have worked in or anyone you know has worked in. A lot of people are on a relatively same wage. If I think of a coffee shop, most people are on minimum wage, and then you might have a manager or two, or the owner, or 2 or 3 owners, they will be on higher wages. So that will be the positive skew. Okay, and then you might have some young people working in the coffee shop, and when they're less than 16, there's a training wage, so that's less than minimum wage, so that's the little tail to the left. Okay, so wages is a good one for positive skew. And then negative skew could be reaction times is a good one for negative skew. So in other words, if you're waiting for a light to turn on and you have to hit a button when the light turns on, then you'll find that very few people hit it really fast, because very few people have really fast reaction times. So there's more of a skew to slow reaction times, and then most people take longer to hit that button. Okay. And then to the right-hand side, the reverse J shape, or kind of like an exponential curve, that one you should recognize. So it starts off high and goes low. Okay, and then the bottom three curves, the first one there is the normal distribution curve, and this is described as two tails. So it has a tail on the left, it's highlighted there, and a tail on the right. Just under it, it just has a negative tail. On the very bottom one then, it just has a positive tail. Okay, so what kind of questions do you get asked? You see that exercise 3.8 here in the Gills book, Project Maths. Which one is which? Okay, you need to be able to look at these and you need to be able to say which one is which. Okay, so the easiest one to spot is the normal distribution curve, so that's E. Symmetrical, you're looking for symmetrical, you're looking for two tails normally, left and right. Okay, A then is follow the tail, so that is negative skew. Okay, and C then is positive skew. Okay, B then is your reversed J, and D is your uniform or your rectangular shape. Okay, I suppose I didn't state that one too much. Do you see on the left of that page, diagram A, that is where all the values are the same. So that's what's called uniform. Well, uniform is what I would call it, or rectangular as well. Okay, just staying on that left-hand side, if we have a look at it, I want to point something out, yes, with E and with B, okay? Are you okay that in B, it is symmetrical and the mean is in the middle? Okay, the average of that is in the middle because it's symmetrical. Okay, if I take you down to E, the mean is also in the middle for E, okay? And the median is also in the middle for E, okay, even though it looks slightly different, because again, it is symmetrical, it's just got a completely different shape. Okay, that doesn't have one mode, that has two modes, so we would call that bimodal data. So that's E. It has two values that occurs most often, the lowest value there, whatever it is that they're measuring, and the highest value. Okay, so bimodal data, it has two modes, whereas B only has one mode. I think that's it on that page. Yeah, so you can see there just the diagrams. There's the bimodal representation that I was talking about, so that has two values that occurs most often. To the right is called multimodal. In other words, if it's more than two, it's multimodal. You can also have data that has no mode. And I'm looking at the histogram above it. Do you see the one that says age of diabetes in years? I would consider that to have no mode. So there's no value that occurs most often there. And if you think about the age that people get diabetes at, which I'm presuming that is, that can be at any age and any stage during the year. So any month, any day. So because you can get diabetes on any day of any year, there really isn't a value that occurs most often. Okay, so that doesn't really have a mode. Okay, and again, that question 9 I'm going to do with you, that was an exam question. I think it was a sample paper. Make sure you can do your stem and leaves. Again, come back to me if you need me to do a stem and leaf question. I have no problem at all doing them. They are well covered in the junior cert course, so most people can do them, but just make sure they are on the Leaving Cert course. As you can see, they've never come up that I can think of off the top of my head. I can't think of any question on a mock or a sample paper where I've seen a stem and leaf, but they are there. So just make sure you can do them. And in scatter plots, then I'll do in the next class. Okay. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice? In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.